So today we're going to talk about zeros, x-intercepts, and solutions. And one of the things that I want to first talk about is that those three terms are interchangeable. Zeros, x-intercepts, solutions. In a problem, if they ask you to find an x-intercept, you're looking for a zero. If they ask you to find a zero, you're looking for the zero, the x-intercept. They're interchangeable. Solutions, solving a quadratic equation. The solutions are at the x-intercept. They are at the zeros. They can word it all these different ways, but you're looking for the exact same thing. So don't get confused in what the problem is asking you. If you see find the zeros, find the x-intercepts, find the solutions, all of those things, this is a way to do that. The zeros, the x-intercepts those are all interchangeable. So how do we go about finding these zeros? Now, the easiest way is to actually use our calculator. So I wanted to show you on your calculator how you would actually go about using your calculator to do this. So let's take a look at our calculator, our lovely TI calculator here. In order to find the zeros of this quadratic, the first thing I'm going to have to do is I'm going to have to go to y equals. So I go to y equals and I plug in the equation. Negative 2x squared minus 3x plus 4. Put that in my calculator and I go to graph. Oh look, lovely little parabola. Please remember, the word zeros is interchangeable with x-intercepts. So my x-intercepts are right there. There's an x-intercept and there's an x-intercept. All right, so I can see on my graph where they are. And that's important because just like with the second trace function, if I can't see it, the calculator won't find it for me. So just like when we were looking for where two lines intersect, we want to go back to that second trace, the calculate menu. Second trace. And down here was where we went before with our intersect, but up here at number 2 is 0. It is an option. Now, what is interesting about the calculator is it doesn't want to have to look at the whole line. It just wants to know what piece of this parabola does it need to look at to find what you're looking for. We're looking for our x-intercepts. Please be aware that there are 2 x-intercepts. The calculator cannot find 2 at a time. It can only find 1 at a time. And so I need to pick one and start with that one. So I like this one on the left. I'm going to start with this one on the left. And I look at it and I'm like, wow, that's somewhere between like -3 and -1. Somewhere between those two. So when it asks me for a left bound, I'm like, well, -3 is over here on the left. So I'm going to type in -3. -3 is on the left. So that's over here. -1 is right here. It's on the right. So I chose -1. Guys, it's going to be different numbers every time. It's going to depend on the problem. You are going to have to physically look at the screen, pick some number that is to the left of that intersect, some number that is to the right of that x-intercept. And then it asks to guess. I don't want to guess. I want it to tell me what it is. And so I look and I've got, oh, -2.35, because as always, we want to round to 2 decimal places. So -2.350 is one of my x-intercepts. That's one of my zeros. Now I need to go back and find the other one. Please be aware, again, it can only find one at a time. You have to go through the process twice to find the second one. So I'm going to go second trace. This time I'm going to choose 0, just like last time. But this time I want to find my x-intercept on the right. So my left and right bound is obviously going to be different. When I look at this one over here, some number that's to the left of it would be 0. So I'm just going to put in 0 as my left bound. Some number that's to the right of it looks like 2. Could have put 3, I could have put 4, I could have put any number to the right of it. I just picked the first one I came to, which was 2. And again, I don't want to guess, I'm just going to hit enter. And it gives me that the 0 is positive 0.85, because again, we're rounding to 2 decimal places. So positive 0.85, 0. That is my other x-intercept. So my zeros are -2.35 and 0.85. Obviously, there are limitations to using the calculator to find our zeros. It can only give us decimal answers. Okay, math enter enter will not work. If you were to just type in -2.35 and then hit math enter enter, you've rounded that decimal. It has changed the fraction, and I cannot tell you guys enough, don't do that. If it is approximated, it is the decimal, and we have to leave it that way. Okay? So that is how I do my calculator to find the zeros. Now here are the steps, just in case you missed those. So 1, put the equation in y equals. 2, you got to graph it, because we need to make sure we can actually see the x-intercepts. 3, we'll go to second trace, the calculate menu, and we're going to choose number 2, the 0. All right? Now we have to give a left and a right bound for one of the zeros. Please remember, you can only do 1 0 at a time. And then we're going to repeat the process for the second 0. So those are our steps for using our calculator to find a 0. So what might we use these zeros for? One of the best things to use them for is for word problems. Most word problems are real-life situations where we are already using decimals. And if we already have decimals in our problem, I can get decimals for my answer. There's no reason for me to go through these long by-hand ways to solve the problem if I'm already going to be rounding my answer. If I have to get an exact answer, which we are going to learn how to do this unit, then this is not the method I want to use if I'm looking for an exact solution. But if I'm dealing with word problems where I've already got decimals, I'm already rounding, I might as well use the quickest way where I can also round. All right, so we use these for word problems. So we can use this method for solving word problems that already have decimals. That way we don't have to worry about exact answers. Big remember, the equation must be equal to 0 before I enter it in the calculator. And guys, this is going to be a theme for this whole unit. To solve quadratic equations, they have to be equal to 0. Point blank. When we solve by factoring, when we solve by completing the square, when we solve by the quadratic formula, all the methods, it has to be equal to 0 to solve in the calculator and for all these other methods. So just remember that when we do a problem. For 1987 through 1994, the number of cell phone subscribers, S, in millions, in the U.S. can be approximated by the model S equals 0.52 t squared minus 7.9 t plus 31.87, where t equals 7 represents the year 1987. In which year did cell phone companies have 7.5 million subscribers? So that's a formula. Guys, the thing I love about quadratic word problems, again, is that they always give me the equation. I didn't have to read and put together this equation. They're going to give it to me. S equals that. Fantastic. And then in the problem, they give me an S. 7.5 million subscribers. Okay, so I'm going to plug that in for S. 7.5 equals 0.52 t squared minus 7.9 t plus 31.87. Fantastic. I just need to solve this for t. I want to know what year did they have that many subscribers. Solve. Solve. Solution. That's interchangeable with x-intercept and zeros. I'm looking for a 0, but in order for me to use that method, this has to be equal to 0. That's the big thing. I've got to make it equal to 0. So to do that, I'm going to subtract 7.5 from both sides. That'll give me 0 on this side. 0.52 t squared minus 7.9 t. And this will be plus. We just need to figure out what is 31.87 minus 7.5. Enter 24.37. All right, this gives me an equation. I don't hesitate. I go straight to y equals. Now that it's equal to 0, I can enter it in. Please remember we can only use x in our calculator, so I am going to have to change those t's to x's. 0.52 x squared minus 7.9 x plus 24.37. All right, let's graph it and see what it looks like. Oh, here's part of it. It looks like it's running off over here. So I am going to need to change my window maybe a little bit, make my x go a little further. Let's try 20 and see if it'll show up now. Oh, great. Now they both show up. I want to find my x values. So let's take a look at both of these answers. So if I'm looking at this one, this looks like 1, 2, 3, 4. And this is where we need to use a little common sense. This is pretty close to 4. And this one looks like 5, 6, 7, 8, 9, 10, like pretty close to 11. Look at our ranges. This is for 1987 through 1994. 1987 through 1994. T equals 7 is 1987. So if I used 4, that's before this equation's even good. This equation was only good for 1987. So I don't want to use 4. I want to choose the one that's actually within that range. So I'm going to try going for this one back here at 11. So second trace, go find my 0. All right. Some number to the left, 9-ish. 9 looks good. Something 12 or 13, right bound, 12 or 13. Yep, that'll do good. And then we hit enter, and it looks like x is equal to 10.89. X equals 10.89. Right? Now, if we did go back and we went back and found this one over here next to 4, second trace, 0. Something to the left could be 3. Something to the right could be 7. Hit enter. It does give me 4.30. All right. But this goes back to putting it in the context of the problem. We want to know, when did cell phone companies have 7.5 million subscribers? This was only for 87 through 94. This year, this would have been 1984. That didn't fall within that range. 10.89, that's going to be 10 years, so that's around 1990, almost 1991, maybe November-ish, or the end of the year. But that's 1990. That falls within that range. So my answer that I'm going to use is going to be the one that falls within that range.